3208, Imaging Equipment and Maintenance. Module 3, the X-ray Imaging System, the X-ray circuit and its section. Objectives. At the completion of this presentation, the student should be able to do the following. 1. Describe the X-ray circuit and its elements. 2. Illustrate and discuss the X-ray control panel. 3. List the different ways in extending tube life. So this is a schematic diagram of the X-ray imaging system. Basically, the X-ray circuit is divided into 3 sections. The control console or the low voltage section, the high voltage section, and the X-ray tube. So we will be discussing each section in the following slides. So again, the X-ray circuit is divided into 3 sections, okay, namely the control console, the high voltage section, and the filament circuit or the X-ray tube. Okay, first, we must go back to the definition of what is the operating console or the control console. So again, what is the operating console? Okay, very good. Yes, it is the control unit and provides control of the line compensation, the kilovoltage peak, the milliampere, and the exposure time. Okay, and they are based on computer technology. And modern X-ray machines or X-ray imaging systems have controls and meters in digital, and the techniques are selected with a touch screen, okay, as shown in the picture. Okay. So another representation or image of the control console. Okay. So as you can see, you can just click in any body part of what to be examined, and then you can adjust the KB, the MA, and the time. You can also select the body habitus, whether table or BCH. Okay. You can also select the size of the focal spot, okay, in the control panel. Now let us view the control console circuit. Okay, so what are those things that are included in the control console circuit or the low voltage circuit? Okay, as you can see here, okay, this is the source, the power source. Okay, it will be going through the line monitor. Okay, so in older machines, we can see the line compensator switch and the meter. But in modern X-ray machines, line compensation is automatic. Okay. So later we will explain what line compensation or compensator is. And of course, the auto transformer. Okay. So the auto transformer is responsible for the line compensation as well as the KBP selection. Okay. We have the KBP major and KBP minor. We also have the KBP meter and the timing circuit and selector. Okay. The operating console, and of course the console will have controls for the following. So what are these, class? Yes, we have number one, the MA and time or MAS, the KVP, the focal spot size, the line voltage compensator, and of course the AEC or the automatic exposure control. So first, the line voltage compensator. Okay, so in the circuit diagram, we can see that the line voltage compensator is located at the bottom left. So this controls the line compensation or voltage line compensation. So bakit ba may line compensation? Okay. So ang pumapasok na voltage sa ating machine is 220 from the do sa source, di ba? 220. Sa lahat ng saksakan natin, it's 220. Okay. So, hindi maiwasan na magkaroon ng fluctuation sa kuryente, sa voltahe ng kuryente. Therefore, sa mga lumang X-ray machine, kailangan lagi nating titingnan yung line compensator meter. Okay? Kailangan lagi siyang nasa 220 at kapag wala siya sa 220, kailangan i-adjust natin yung line compensator. Pabalik sa 220. Okay. So, after that, the voltage supply will go to the auto transformer. So the main purpose of the line voltage compensator is for us to have a uniform and consistent, accurate voltage supply required for radiographic procedure. Now we go to the second part, which is the auto transformer. Of course, we know that the auto transformer is a single winding, okay, represented by the single winding, okay, and one core. Okay, but this single winding can have a number of connection or electrical taps. Okay, as we can see here, okay, the auto transformer, okay, so you can see that there are different taps for the different kilovoltage peak. Okay. So the auto transformer is designed to supply voltage of varying magnitude to several different circuits of the X-ray machine, including both the filament circuit and the high voltage circuit. So meron din niya papunta sa filament transformer or filament circuit, as well as towards the primary high voltage transformer. Okay? So, lahat ng voltage ay dadaan ng auto transformer. So, remember that in this side, it is still low voltage. Now, the KV selector. In the circuit diagram, it is represented by this. Okay? Okay, but in the control console, actual control console or operating console, it can either be represented by two knobs representing the major KBP selector and the minor KBP, or by touch screen. Okay. So for the KBP major, the increment is of 10 or by 10 ang kanyang adjustment. When you when you turn the knob forward, it will increase 10. When you turn the knob left side, it will decrease by the value of 10. But the minor KBP selector is in increments of 2. So if you need 72, 73, 74, so you just need the KBP minor selector. Okay? So basically, kaya nga siya KBP selector, this is uh, where we select the kilovoltage peak. So next is the MA selector. So the tube current, as we remember, is adjusted and controlled by the filament current. Very good. So the tube current, the number of electrons crossing from the cathode to anode per second is measured in, of course, milliampere. Okay. So the quantity of electrons is determined by the filament temperature. And the voltage is provided by the taps of the autotransformer. And this voltage is reduced with precise resistors to a value corresponding to the milliampere stations available. Okay, so milliampere. Okay, so milliampere is responsible for X-ray quantity. In continuation with the MA control or MA selection, so tube current is usually not a continuous variable. Usually, they are only represented by certain numbers of or currents of 50, 100, 150, 200, and 300 MA or higher if they are provided by the manufacturer. Okay, so ito lang yung ating pamimilian. And then after selecting this, we will be choosing the time in order for us to have the MAS. So the voltage is then delivered to the filament transformer. So from the auto transformer, mamimili tayo ng MA, and then from the MA selector, pupunta siya sa filament transformer. And this filament transformer is a step down transformer. Okay, so the filament transformer lowers the voltage. Okay, kaya siya ay step down. Then the selection of the small or large filament is connected to the MA selection or as a separate control. Okay. That's a very important thing in the low voltage section or the control panel or operating console is the exposure timers or the timing circuit and selector. So of course, there are different types of timers used in the X-ray imaging system. So the timer circuit is a separate circuit from other main circuit. So it consists of a mechanical or electronic device whose action is to make and break the high voltage across the tube on the primary side of the high voltage section. So yun ang kanyang primary function. Okay? So other functions of the control console. So the console will also have the exposure button or buttons. Okay, the prep button is depressed to prepare the tube for exposure. Okay, the rotor will spin up to 3,400 revolution per minute. With the exposure button, so a green light will let you know that the machine is ready to make the exposure. Minsan kasabay nito yung tunog ng machine. When you press the rotor or the prep button, then the green light will turn on, and then you will also hear a sound, a click in the machine. Then you can make the exposure. So the exposure button is then depressed and the exposure is initiated. So the button must be held down until the exposure is complete. The exposure control buttons are referred to as a dead man switch because it requires pressure in order for the exposure to be completed. After the buttons are released, the rotor motor reverses and the rotor reduces the speed from 3,400 revolutions per minute. Okay, next is the high voltage section. So the high voltage section converts low voltage from incoming power to kilovoltage of correct waveform. It consists three primary sections: the high voltage step-up transformer, the filament transformer, and the rectifiers. Okay, all components are immersed in oil. Okay, what is the function of oil? Oil serves as the insulator or insulating material. It helps in the dissipation of heat. Okay, so again, the high voltage section primary function is converting voltage to kilovoltage. Before I forget, kaya tinawag natin na low voltage dun sa operating console is because uh, it is only 220 volts that are supplied in that circuit. Why? Because in order to protect the radiologic technologies from electrical shock. However, this high voltage section is located in the transformer or high voltage generator. The high voltage transformer. So of course, it is a step-up transformer from voltage to kilovoltage. Okay? The only difference between the primary and secondary waveform is the amplitude. Okay, yung taas ng wave. But they are both sine wave or sinusoidal wave. Okay? The turn ratio for most X-ray high voltage transformer is between 500 and 100 turns. And then the incoming voltage, as I said, is converted into kilovoltage. When talking about high voltage generator, we must also talk about voltage rectification. Okay. We all know that the transformer, high voltage transformer, receives an alternating current, but the X-ray tube circuit utilizes direct current. So in order for us to change the alternating current to direct current, we must rectify the voltage by use of diodes. Okay. And the process in which we convert AC to DC using diodes as rectifiers are called or is called rectification. Okay. There are three types of rectification: self-rectification, half-wave rectification, and full-wave rectification. First, self-wave rectification, a reference to the fact that electrons cannot flow from anode to cathode in an X-ray tube. So the X-ray tube serves as the vacuum tube rectifier. So meaning the X-ray tube acts as its own rectifier. Kaya nga siya ay self-rectification. And the waveform for self-rectification is the same as half-wave rectification with 60 pulses per second or 60 cycles per second. Okay. So half-wave rectification. So voltage is not allowed to swing negatively during the negative half of the cycle. So kaya siya ay, kung makikita nyo dito sa kanyang waveform, instead na sinusoidal wave, pagdating doon sa negative swing niya, siya ay magiging flat doon sa line. Okay? Kaya siya tinawag na half wave kasi kalahati na lang ng wave yung natira. So half wave rectification uses 1 or 2 diodes. Okay, 60 pulses per second. And disadvantage, it wastes half of the power supply. Okay, it also requires twice the exposure time. Okay, unlike in the full wave rectification, okay, the negative half cycle corresponding to the inverse voltage is reversed. Okay, so meaning from this waveform, okay, from this waveform, sa normal na voltage waveform niya, or sa alternating current waveform, okay, magiging ganito. Okay? So, itong pink na to, instead na dito siya sa baba, okay, mag-flip over siya into another positive wave. Okay? So, lahat yun ay dire-diretso. So, kung yung half wave rectification ay nagiging flat, ito ay nagiging isang buong crest. Okay, kaya siya ay instead na 60 pulses per second ay naging 120 pulses per second. Okay, diodes na ginagamit niya ay 4 and advantage yung exposure time niya ay nare-reduce sa kalahati. So same goes dito, di ba? Okay. Tingnan niyo yung pathway, isang way lang ang pinanggagalingan or ang dinadaanan. These are the diodes. Okay. So again, diba, ordinarily we have the voltage waveform na ganito, di ba? Okay. Then kapag half wave rectification. Okay, nagiging siyang ganyan. Okay, then full wave rectification. Okay, ganyan ang full wave rectification. Okay, the normal AC voltage waveform, the half wave rectification, and then the full wave rectification. Okay, two diodes, four diodes. Okay. Now the last section of the X-ray circuit is the X-ray tube section. It is where the thermionic emission is happening and where the X-rays are produced. Extending X-ray tube life is a must-know for radiologic technologies. Okay? So there are many factors affecting X-ray tube life. So of course, kailangan we must use minimum radiographic technique factors. Okay? Bakit kailangan? In order for us to minimize the production of heat. Okay? So decrease excessive heat. That is the key to extending X-ray tube life. Because the number one cause of X-ray tube failure is tube heat, tube overheating. Okay? Okay, there are three ways of heat dissipation. So we have radiation, conduction, and convection. So ano bang pagkakaiba ng tatlo? Okay, anyone? Okay, let us see kung tama ang inyong mga kasagutan. One, radiation. So, transfer of heat by emission of infrared. Then conduction, transfer of energy from one area of an object to another. Then last is convection, transfer of heat by the movement of a heated substance from one place to another. So these three are ways of heat dissipation. Okay, so convection, yan yung ginagawa ng ating insulation. Diba? Yung ginagawa ng ating oil, kung saan nakababad ng ating mga high voltage circuit element. Okay. Then what are the causes of tube failure? So, tingnan natin. A single excessive exposure. Okay? So, yung mataas na technical factors in a single exposure. Mataas na yung MA mo, mataas na yung KB mo, mataas pa yung time mo. So, it will cause heating or cracking of the filament. Then, long exposure time causes excessive heating of the anode. So ano magiging resulta? Damage to the bearings of the rotor assembly. Okay, it causes warping or rotational friction on the anode. Okay, then vaporization of the filament. So ito yung pinakadelikado. Pag nag-vaporize yung filament, so there is no choice but to replace the whole X-ray tube. Diba? So it causes the tungsten to coat the glass or metal enclosure. So pag nag-vaporize siya, matutunaw yung filament. So ang nagkakos nito ay yung arcing. Arcing. Yung pagkakaroon ng spark doon sa loob ng filament, yung uncontrolled sparking or yung tinatawag natin arcing due to ionization of air or gases inside the uh, vacuum tube. So supposed to be dapat walang air doon, di ba? Kasi vacuum tube ang ating X-ray tube. So, yan. So ano yung maaaring makatulong to extend the tube life ng X-ray tube? So kailangan proper warm up ng X-ray tube. So before using the X-ray tube for the day, kailangan i-warm up into different kV and MA. Okay? Siyempre, kung matagal na hindi rin nagamit, i-warm up din natin ang ating X-ray machine. Okay? Then, of course, avoid single excessive exposure. Avoid long exposure time. Kaya minsan maririnig natin, pagpapahingain lang po natin ang makina. So, yun yung ibig sabihin sa long exposure time. So, maaaring sobrang dami na X-ray procedure na naganap within a particular hour. Kaya kailangan pagpahingahin ang X-ray tube. Okay? So the most frequent cause of abrupt tube failure is electron arcing from the filament to enclosure due to vaporized tungsten or filament. Here are my references. Thank you for listening to my lecture. Okay. So